the next set of problem is a similar kind, but in this problem we can see that we have to construct a DFA to accept a decimal string, okay, instead of a binary string. Here it is decimal string that is divisible by 3. So again we are going to find out what is the radix here. So the radix would be 10 here because we are using the decimal strings here, and then the decimal input symbol or the digits that we are going to use is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the possible reminders are, so that is I is equal to 0, 1, 2. Again the same thing, it is 0 mod 3 is 0, 1 mod 3 is 1, 2 mod 3 is 2, 3 mod 3 will produce a 0, 4 mod 3 is 1, 5 mod 3 is 2, 6 mod 3 is 0. So this is the possible reminders that we have, and K is the divisor is 3. Okay. Now to construct this, so what we'll do is, first among these digits, we'll find out the ones that produces the reminders 0, 1, 2, 1 and 2. So in this case, if you see, if I take the set 0 and 3, 6, 9, so all this will give me a reminder of 0. So similarly, if I take the next combination of 1, 4 and 7, so this will give me a reminder of 1. So the next one is, if I have 2 and then I have 5 and 8, this will give me the reminder of 2. Okay. So these are the set. So I'll be making use of 3 states, which is Q0, Q1 and Q2 in the problem. Now we have to compute the transitions. Now to compute the transition, so first let me start for, so I'll just write down this here. So 1, 4, 7 will give me a reminder of 1, and then 2, 5, 8 will give me a reminder of 2. So now we'll start computing the transition. So for I equal to 0. So I'm going to compute the transition for 3 things. I equal to 0, I equal to 1 and I equal to 2. Okay. So starting with I equal to 0, the same formula, I'll be using R into the value of I, which is 0, plus the digit that I'm using. So it is on seeing a 0, mod the divisor is 3. Okay, so this would be the first transition. The second transition would be 10 into 0 plus on seeing a 1 mod 3, and then the next transition would be 10 star 0 plus 2 on seeing a 2 mod 3. So when I tell 0 here, this actually signifies to 0, 3, 6, 9. When I tell a 1 here, this actually signifies to the set 1, 4 and 7. So when it is 2 here, it signifies the set 2, 5 and 8. Okay. So we'll see what is the transition. So we'll start with delta Q0, because I'm starting from I equal to 0. On seeing a 0, so compute the next state. So this is 0 mod 3. So this will give me 0. So 0 mod 3 is 0. So I stay in the state Q0. In the next case, this is 1. So this gives me 1, 0 plus 1 mod 3. So this is 1 mod 3. So delta Q0 comma 1 will give me the next state, which is Q1. And the next one will be delta Q0 comma 2 will give me, so this is again, it is 2 mod 3. So this is 2 mod 3 will give me 2. So I can write the state Q2. Now for I equal to 1. So in case of I equal to 1, I can write the states. The next state can be computed as 0 into 1 plus 0 mod 3. And then the next transition would be 0 into 1 plus 1 mod 3. And then we'll have 10 into 1 plus 2 mod 3. Okay, so we'll see the transition here. So this gives delta. So I equal to 1, so this becomes Q1. And then on seeing a 0, now compute the next state. So this is 10 mod 3. So 10 mod 3 is equal to 1. So I'll write this as Q1. So the next one is delta Q1 comma 1. So here we have 11 mod 3. So 11 mod 3 is Q2. So I'll write this as Q2. The next thing that we have is delta Q1 comma 2. So for delta Q1 comma 2, this is 12 mod 3. So 12 mod 3 is 0. So I'll write the state as Q0. So only thing to be remembered that every reminders that I have here, this is actually giving me a state. So I have Q0, Q1 and this one for Q2. Okay. Now coming for the last set for I equal to 2. So again it is 10 into 2 plus 0 mod 3 and then we'll have 10 into 2 plus 1 mod 3 and then we'll have 10 into 2 plus 2 mod 3. So in this case we have 12 mod 3. Okay, so here we have Q2 comma 0. So in case of Q2 comma 0, so this gives me 12. 12 mod 3 is Q0. And this is 20 mod 3. So 20 mod 3 will give me Q2. And the next condition is delta Q2 comma 1 on seeing a 1. So this gives me 21 mod 3. So 21 mod 3 will give me Q0 and this would give me 22 mod 3. So delta Q2 comma 2. So I'll be getting this as 22 mod 3. So 22 mod 3 is equal to 1 is a reminder. So I'll be writing this as Q1. Okay. So this is how we compute the states. Now based on the states, we'll be drawing the state transition diagram. So here you can see that I'll have 3 states, which is Q0, Q1 and Q2. Okay. So I'll start with the start state, which is Q0. Q0, on seeing a 0, we reach Q0. So when I tell 0, this is actually signifying the set 0, 3, 6, 9. Right? So on seeing a 0, so instead of writing a 0, I can replace this as 0, 3, 6, 9. Okay? So we remain in the same state. Q0, on seeing a 1, we make a transition to Q1. So Q0, on seeing a 1, we make a transition to Q1. So 1 in sense, it is 1, 4, 7. So I will replace this with 1, 4, 7. Okay. In the next case, let me come to Q2. So Q0, on seeing on accepting 2, it makes a transition to the state Q2. So on seeing a 2, it makes a transition to Q2. So 2 can be written as 2, 5, 8. So whatever we have got here, 2, 5, 8. Now coming to the next one, Q1. Q1, on seeing a 0, it remains in the same state, which is Q1. So 0 in sense, it is 0, 3, 6 and 9. And then Q1, on seeing a 1, it makes a transition to Q2. So on seeing a 1, I can write this as 1, 4 and 7. And then Q1, on seeing a 2, makes a transition to Q0. So Q1, on seeing a 2, makes a transition to Q0. So 2 is 2, 5 and 8. Right? Now coming to the next one. So I'm done with this. Then, so let me come here. Q2, on seeing a 0, it remains in the same state. So Q2, on seeing a 0, remains in the same state. So which is 0, 3, 6 and 9. Okay. Q2 on seeing a 1 makes a transition to Q0. On seeing a 1 makes a transition to Q0. So I can write this as 147. And then Q2 on seeing a 2 makes a transition to Q1. On seeing a 2 makes a transition to Q1. I can write this as 2, 5 and 8. Okay. So which would be the final state, because it should accept the DFA should accept all the strings that is divisible by 3. So anything that is divisible by 3, it will produce a remainder of 0. So in that case, Q0 itself would be the final state. Okay. So this is most important one. So let's go to the next problem. Okay. So the last set of problems in the DFA is modulo K counter problems. So we'll see the first problem under this. So the question reads that we have to obtain a DFA to accept the language, and what the language gives here is that the length of the string mod 3 should be equal to 0. And you can see that what's the language that it should be accepting? It is A, which means that if suppose my string has got a single A, so what's the length of the A here? So it is, so if there is nothing, then it is 0 mod 3. So which is equal to 0. If my string has a single, my language has a single A, the length of this is 1. So 1 mod 3, it should give me 1. So if I have 2 A's here, so it is 2 mod 3, it should be 2. If I have 3 A's, so 3 mod 3, it should be 0. So again, if I have 4 A's, it should be 4 mod 3, which is equal to 1, and so on. Okay. The condition tells us it should accept all the string that satisfies whatever condition is given in the language, which is equal to, that is, the length of the string mod 3 should be equal to 0, which means that this should be accepted, this should be accepted, and so on. 6 mod 3 should be accepted. Okay. So to draw the DFA for this, so we'll start with the number of states. So how do we get to the number of, know the number of states is based on the reminders. So here you can see that it produces 3 reminders, 0, 1, 2. So the states would be Q0, Q1, Q2. Q0 signifies the remainder 0, Q1 signifies the remainder 1, and Q2 signifies the remainder 2. So we'll start with the DFA here. So I'll start with Q0, right? And then we'll have Q1, and then we can have Q2. So I can write Q2 here. Okay, so we can have Q2. So in this case, now let's see how this works. Now starting with Q0, I remain in the same state, which indicates 0 mod 3 is 0. So I'm here in 0 here. Now what happens when I see a single A? So when I see a single A, that means 1A, in sense it is 1 mod 3, I should go to the state Q1. So on seeing a A, it makes a transition to Q1, which indicates that it is 1 mod 3, and this gives me the state there. So the second thing, if I have 2 A's, so on seeing 1A, I reach Q1. On seeing the next A, what happens? This is the same thing as 2 mod 3, you reach the state Q2. So I go to Q2. Okay. Now what happens when I see the third A? So when I see the third A, you can see that it gets back to the state 0, which is Q0. So on seeing the third A, it goes to Q0. Now you can see that since the question tells that the length of the string mod 3 should be equal to 0. So everything that is 0 mod 3, 3 mod 3, all this should be accepted. So since it should be accepted, Q0 will become the final state. Now let's see this. Now if suppose I have 5 mod 3. So if I have 5 mod 3, so this will give me 2, right? So 5 mod 3 is 2, which means that when I do the transition, this I should end at state Q2. So let's see this. So first time when I see a A, so this is same thing as seeing 5 A's. So when I see the first A, I reach Q1. When I see the second A, I reach Q2. When I see the third A, I reach Q0. The fourth A, I reach Q1. The fifth A, I am in the state Q2. So which is Q2. If I see the sixth A, this should be accepted. So this will reach the final state here. So this is a basic example of the modulo K problem. So with this, I'll end up with today's session. And in the next class, we will see some more topics on NFA and epsilon NFA. So the next problem on modulo K is to obtain a DFA to accept the language. And the condition that's given in the language is that the length of the string mod 3 should be greater than equal to the length of the string mod 2. So what we do here is we have seen this as an individual problem. So we have two conditions here. The first thing is all the string that belongs to that is divisible by 3. So in this case, if you see, you know that Q0 on accepting an A, it goes to Q1. That is 1 mod 3 will go to the state Q1. 2 mod 3 it goes to the state Q2. 3 mod 3 it goes to Q0. So and so on. So this gives the DFA for the first condition. Similarly, the DFA for the second condition is that so it is 0 mod 2 will give me 0 and then 1 mod 2 will give me 1 and then 2 mod 2 will give me 0. Okay. So we start with 0 here. When we see the length of the string as a single A, it goes to Q1. When we see 2 A's, which is the length of the string, it goes to the state Q0 and so on. This continues. Now, we have two conditions and both are together given as a condition in the language here. Now, what we do is, we take both the states and do a cross product here. So, for example, in this case, if you see here, we have this reminders as 0, 1, 2 and here we have the reminders as Q0 and 1. Now, we are going to find out the cross product of, I'll take this as Q1 and this as Q2. So, I'll take the cross product of this. So, which is 0 into 0 is the first one, 0, 0. The second one is 0, 1. The third one is 1, 0, 1, 1. And the next one is 2, 0, 2, 1. Okay. Now, this will be my states. So, I'll have this as the states. So, based on this, I'm going to find out what is the transition. Now, to find out the transition, so what we do is, I know what are the states. Now, we'll start with the transitions. So, I'll start with delta and the initial state is Q0, 0. I'll take this as Q0. Okay. On seeing A, because I have a single input symbol, which is A. So, on seeing A, what happens? So, it's the same thing as writing delta 0, A and delta 0, A. Okay. So, when I take delta 0, A, this is for mod 3 and this is for mod 2. So, in this case, you can see that Q0 on seeing A, it goes to Q1. So, I get this as 1 and then here you can see that Q0 on seeing A, it goes to the state Q1. Okay. Now, this becomes my next state. I'll take this as Q1. Okay. So, this is same thing. So, I'll write this as Q1. Now, again, I'll start with the next one. My current state is Q1. So, I can write it as 1, 1. So, this is the state Q1 on seeing an A. So, A is the only input I have here. So this is, I can write this as 1, A, delta 1, A. Okay. So, what we'll do is, we are in the state Q1. On seeing the next day, you can see that it makes a transition to 2, right, to the state 2. Now, here, on seeing from Q1, on seeing the A, it makes a transition to 0. So, this becomes my next state, which is Q3. Okay. Now, similarly, we'll proceed on. So, I'll start with delta 2, 0, A. So, here we have two states. So, delta 2, A and delta 0, A. Now, again, I'm in the state Q2 on seeing the A, I reach Q0. So this is 0 here. I reach the state Q0. Again here, I am in the state Q0. On seeing the A, I reach 1. So 0, 1 is my next state. So I take this as Q4. Okay. Now we'll start again with the next thing. So delta. So this 0, 1 becomes my current state, comma A equal to delta. So this is the same thing as 0, comma A and delta 1, comma A. Now for 0, comma A, I am in the state 0. On accepting A, I reach 1. Okay. And then, so I am in the state 1. On accepting A, I reach 0. So this becomes my next state, which is Q5. Okay. Now proceed on similarly. Now we'll see the next state, delta. So I have 1, 0, comma A. So this is the same thing as delta 1, comma A and delta 0, comma A. Okay. On seeing 1, comma A, so here 1 on seeing an A, I reach 2. And then 0 on seeing a A, I reach 1. So which is 2, comma 1. So that's my next state. So I start with 2, comma 1 is my current state, comma A. So I get delta 2, comma A and delta 1, comma A. I'm just splitting this and writing. It is 2, comma A and 1, comma A. So delta 2, comma A is, I am in the state Q2. On accepting A, I reach 0. Okay. I am in state Q1. On accepting A, I reach 0. So you can see that I can stop at this point because I have covered everything. And then we have reached back to 0, comma 0. Now what we do is, we'll write down the transitions for this. So you know that we have 5 states. So I'll start with 0, comma 0. Next is, so the next state is 0, comma 1, or I can write it as 1, comma 1. So 1, 1, comma 1. Okay. So the next state that I have here is 2, comma 0. The next one is 0, comma 1. And the next state is 1, comma 0. 1, comma 0 is the state here, Q5. And then I have the next state as 2, comma 1. So 2, comma 1. So 2, comma 1. I've covered all the 6 states here. Now what we do is, now start with 0. 0, comma 0. So you can see here 0, comma 0. On seeing a A, it makes a transition to Q1. So on seeing a A makes a transition to Q1, which is 1, comma 1. So I am in the state 1, comma 1. On seeing a A, it makes a transition to 2, comma 0. So on seeing a A makes a transition to 2, comma 0. And then again I have the third condition. My current state is 2, comma 0. On seeing a A, it makes a transition to 0, comma 1. So I make a transition here. Now the current state is 0, comma 1. On seeing a A, it goes to 1, comma 0. 1, comma 0. And then I am in the state 1, comma 0. On seeing a A, we reach 2, comma 1. Okay. I am in the state 2, comma 1. On seeing an A, I reach 0, comma 0. So I reach 0, comma 0. Now what's the condition here? The condition tells us the length of the string mod 3 should be greater than equal to the length of the string mod 2. So which means that you can see here it is greater than equal to. So this, because 0 and 0 is equal, so this could be the final state. 1 and 1 is equal, so this can be the final state. 2 and 0 is equal because 2 is a value that is greater than 0. This is the final state. 0 and 1 is a non-final state because 0 is less than 1. So I'm now going to consider this. 1 and 0 is a final state. 2 and 1 is a final state. Okay. So this is the last problem of DFA. And with this, we wind up with the session on DFA. And in the next session, we will be seeing problems on NFA and epsilon NFA. So thank you.